The topic of this video is creating polynomials using their characteristics. Let's solve this problem. Okay, so the first step in solving a problem of this type is to create a column for factors and to recognize that the factors are determined by the roots. For example, if you have a root of 8, then that must have been created by a factor x minus 8. And if you have a root of 3, that must have been created by a factor x minus 3. The multiplicity tells me how many of these factors I need. So I need one x minus 8, but I need 2 factors of x minus 3. All right, now I'll go ahead and create my function. F of x equals, the first thing you write is the leading coefficient, which is 1, then each of your factors, which would be x minus 8, x minus 3, x minus 3. Now simplify. Anything times 1 is itself, so we get f of x equals x minus 8, x minus 3, x minus 3. This is our final answer in factored form. However, this problem requires us to also write our answer in standard form. To do that, we need to multiply together all 3 of these binomials. Order of operations says you should multiply from left to right. So we'll start by focusing on these 2 binomials, and we're going to multiply them using the FOIL multiplication method. So, the x times the x makes x squared. The x times the subtract 3 makes subtract 3x. Subtract 8 times x makes subtract 8x. And the subtract 8 times the subtract 3 makes plus 24. All of this still needs to be multiplied by the outside binomial, x minus 3. Of course, we have some like terms to combine, which we'll do in the next step, getting x squared minus 11x plus 24. And that has to be multiplied by the x minus 3. Now we have to find a way to multiply this binomial times the trinomial. We can't use FOIL. FOIL is only for binomial times another binomial. But we can use something that is very similar in concept, which is to say, each term of the binomial needs to be multiplied by all terms in the trinomial. Here's what it looks like. The x gets multiplied by all 3 of these terms, and the subtract 3 gets multiplied by all of these terms to create 6 terms. Those 6 terms will be x times x squared is x cubed, x times subtract 11x is subtract 11x squared, x times add 24 is add 24x, subtract 3 times x squared is minus 3x squared, subtract 3 times subtract 11x is add 33x, and subtract 3 times add 24 is subtract 72. We've got some like terms to combine. Specifically, this minus 11x squared minus 3x squared, and this plus 24x plus 33x. Combining our like terms gives us our final answer. F of x equals x cubed. The minus 11x squared minus 3x squared makes minus 14x squared. The plus 24x plus 33x makes plus 57x minus 72. This is our answer in standard form. Okay, we have our 2 final answers, but let's do a quick double check just to make sure we've met all of the criteria. We need degree 3 with a leading coefficient of 1. For a polynomial in standard form, the leading term tells you both of those things. The highest exponent is the degree, 3, which matches, and the coefficient is the leading coefficient, 1, which matches. For a polynomial in factored form, the leading coefficient would be any number in front of the first set of parentheses, which in this case is a hidden 1, and the degree comes from adding the degrees of each of the polynomials being multiplied. This is degree 1, and degree 1. Adding those together, 1 plus 1 plus 1 is 3. This gives us the confidence that we've answered this question correctly.